In part G of this problem, we have to first of all calculate y of negative 0.1 and y of positive 0.1. So we literally just plug in negative 0.1 for the x's. 10 times negative 0.1 is our numerator. Oops. In quantity, negative 0.1 squared plus 1 will be our denominator. That's going to give us negative 1 on top. And then, let's see, 0.1 squared would be 1/100th. Plus 1 would be 1.01. So we're going to be really close to negative 1. In fact, I think it ends up, if you round it off, it's like negative 0.99. And as we found out when we were doing part A, if you plug in the opposite sign of x for this particular function, you'll get the opposite sign of y as a result. So y of positive 0.1 we would expect to be like positive 0.99. And if you do the math, you should find that's true. Then they want us to use these calculations to approximate the slope of y when x equals 0. All right. Well, 0 is perfectly in between negative 0.1 and positive 0.1. So if you imagine a secant line connecting these two very close by points, we just have to find the slope, which is delta y over delta x, of that secant line. Well, delta y is going to be the second y value minus the first y value. So that's 0.99 minus negative 0.99. Delta x is going to be the second x value minus the first x value. So 0.1 minus negative 0.1. So on top, we have 0.99 essentially plus 0.99, which is 1.98. On the bottom, we have 0.1 essentially plus 0.1, which is of course 0.2. Dividing this out would give us 9.9. So pretty close to 10. Now, if you go back to the actual graph, we just drew in the line that goes through 2 points very close to 0 and found that it has a slope pretty much of 10, which is consistent. The graph is very steep right here. A slope of 10 at that particular moment is consistent with what the graph is showing.